see about the topic defects in solids. What is a perfect solid? So, an ideally perfect crystal will contain the lattice point throughout the crystal structure. So, it has a perfect arrangement of crystal structure. So, how do this imperfection comes from? Where do this imperfection comes from? It is the deviation of a lattice point is called an imperfection in a crystal structure. So, ideally imperfect crystal structure arises from the imperfect periodic arrangement of the constituents. So, these defects are divided into two. They are stoichiometric defect and the non-stoichiometric defect. The defects of solids are divided into two, and they are stoichiometric defect and the non-stoichiometric defect. Let us see about the stoichiometric defect. What is a stoichiometric defect? There are two types of stoichiometric defects. So, the first one will be Schottky defect. What does the Schottky defect tell about the defect of crystal? So, this defect arises when some cations and equal number of anions are missing from their own position. So, this defect says that when an equal number of positive and an equal number of negative ion is missing from its lattice side, then that defect is defined as Schottky defect. Some of the examples are sodium chloride, cesium chloride, potassium chloride and potassium bromide are some of the examples of Schottky defect. So, the Schottky defect generally occurs in compounds which are having high coordination number. This is called Schottky defect. Second one, let us see about the Frenkel defect. What is a Frenkel defect? So, this defect arises when one of the ions leaves its own position and occupies an interstitial position. So, what is a Frenkel defect? Let us see at the diagram. So, this will be the diagram for a Frenkel defect. What does a Frenkel defect says? When one of the ions, either positive or either negative ion, occupies an interstitial position, then this defect is termed as Frenkel defect. Some of the examples of Frenkel defect are silver bromide, silver chloride, silver iodide and zinc sulfide are some of the examples of Frenkel defect. Frenkel defect generally occurs in low coordination number compounds. So, compounds which are having low coordination numbers will have Frenkel defect. Now, let us see about the next defect of solids. So, the next defect of solids will be non-stoichiometric defects. What are non-stoichiometric defects? The non-stoichiometric defects are divided into two. They are metal excess defect and metal deficiency defect. They themselves are divided into two cases. So, metal excess defect is divided into two and metal deficiency defect is divided into two. First, let us see about the metal excess defect. What is a metal excess defect? So, in the first case, a negative ion may be absent from its lattice side and occupied by an electron. So, this will be the diagram for metal excess defect first case. So, in this, a negative ion is missing from its side and that lattice side is occupied by an electron. So, this defect will be called as metal excess defect. In the second case, positive ion occupied by interstitial position. When a positive ion and an electron occupies an interstitial position, this effect is termed as metal excess defect. So, there are two cases in metal excess defects. Secondly, the metal deficiency defect. In metal deficiency defect, there are two cases. One case, a positive ion balanced by a 2+ charge. In this case, a positive ion is missing from its lattice side, but the adjacent lattice side is having a 2+ charge. So, the missing side is balanced by a 2+ charge from its adjacent metal ion. This is the first case of metal deficiency defect. In the second case, there is an extra negative ion which is also balanced by the adjacent 2+ ion. So this defect is also termed